Hi guys, this is video 9.7. Today we are talking about independent and dependent events. This would come in like if you're rolling the dice, like in Yahtzee, would be dependent events. You roll all 5 dice and then you pull aside the ones you want to save and you roll the others. Your second and third rolls are going to depend on how many dice you have and what you took out of the pile before. Okay, so that would be your dependent events. Independent events would be if you're rolling the dice and you continue rolling all of the dice every single time to add to your score. So an independent event is going to be the occurrence of one event does not affect the probability of another event. Rolling all the dice at the same time, one dice is not going to affect what a different dice's outcome is going to be. While a dependent event is going to be where the occurrence of one does affect the probability of another. So if you have 3 names in a hat and you draw a name and then you draw another name, your probability of your second draw is going to be changed because you removed a name from the hat. So drawing 3 cards from the deck without replacing them and then drawing 3 more cards. When you're tossing a coin, tossing heads on a coin flip and then tossing it on the same coin, but you're tossing the same coin so it doesn't affect the 50-50 chance of getting heads versus tails. So let's find the probability of an example of the independent events. When you do this, you'll find your probability of your first event and of your second event, or your third and your fourth and your fifth, and you're going to multiply your individual probabilities together to find the probability of the overall occurrence. For example, let's say we had a spinner that has 5 numbers on it. Pretend those wedges are all the same. And we've got 1, 2, 3, 4, 5. In order for all the outcomes to be equally likely, the wedges would all have to be exactly the same size. So let's see what the probability of spinning a 5 all 3 times if we're spinning our spinner 3 times. Now, when you spin the 5 the first time, you don't get rid of the 5. You keep spinning the same spinner. So the probability of spinning a 5 one time would be 1 in 5. So for the probability of spinning a 5 3 times in a row, you're going to take your probability of each individual one and multiply them, giving you 1 over 125, 1 in 125 chance. And when you multiply that out, that would be 0.008. So let's try another one. An experiment consists of spinning the spinner 3 times. For each spin, all outcomes are equally likely. What is the probability of spinning an odd number all 3 times? So the probability of spinning an odd number out of that, when you've got a 1, 2, 3, 4, and a 5, we've got 3 different odd numbers. So the probability of spinning an odd number is going to be 3 in 5. So for all 3 times, you would do 3/5 times 3/5 times 3/5, which would be 27 1/25. And then if you put that into a probability decimal, that would be 0.216. Much more probable to spin an odd 3 times rather than just saying you're going to spin a 5 3 times. Now, if you have 2 dependent events, so let's say we remove whatever it is that we're doing. So we're drawing marbles out of a bag. If what you don't put them back, then your second event is dependent on what is left now. And so it's going to be a whole new probability. And in that case, you'll calculate the probability for the first event and then calculate the probability for the second event, assuming that the first event occurred, and then you multiply the 2 probabilities. So here's what I mean. Let's say a drawer contains 10 black socks and 6 blue socks. Not pairs, just socks. You got 10 black ones and 6 blue ones. If 2 socks are chosen at random, what is the probability of getting a pair of black socks? We're talking, if we choose 2 socks, what's the probability of each sock being black? So for the first one, we have a total of 16 and we have 10 black ones. So the probability of getting black on our first draw is going to be 10 in 16. Now, if there's a black sock taken out, then the probability of drawing a black on this second one isn't going to be 10 and 16 anymore, because now there's not 16 socks and 10 of them aren't black. Now we're going to assume that the first one drawn was black. The second one, the second event, would be 9 out of 16. I mean 15, not 16, because there are now 15 socks because one's been taken out, and 9 of the ones that are left are black. So we'll take these two and multiply them. Now I'm going to go ahead and reduce them because that'll make it easier. So my 10/16, I'm going to reduce that down to 5/8. And my 9/15, I can reduce that down to 3/5. So I'm going to take my 5/8, multiply that by my 3/5, and get 15/40, which reduces down to 3/8. So there's a 3/8 chance in getting 2 black socks. All right, so this time let's see, what is the probability of getting a pair of socks that are the same color? Not that they're both black, but that they're both the same color. All right, so there are 2 possibilities. You could either draw 2 blacks or 2 blues. Now, because if you're getting a pair that's the same color, they're going to be mutually exclusive. They're either going to be black or they're going to be blue. They're not going to be a pair of socks that's black and blue, right? Because that wouldn't be a pair of the same color. We've already found the probability of getting a pair of black. The probability of black was 3/8. So let's find the probability of getting a pair of blue ones, and then I'll show you what to do next. So let's say we want to draw a blue one first. The probability of drawing a blue one first is going to be 6/16, which reduces down to 3/8. Assuming that we took a blue one first, let's find the probability of a blue one on our second draw. That would be 5/15, which is 1/3. So probability of a blue pair is going to be 3/8 times 1/3. Our 3's will cancel here, leaving us with 1/8. So we have a 1 in 8 chance of getting a pair of blue. Now, like I said, the pair of blue and the pair of black are mutually exclusive. So in order to find the probability of getting a pair of socks that's the same color, I'm going to add them. Now, you may have trouble deciding when to add probabilities and when to multiply them, because here we multiplied them. In the previous section, we added them. So if your outcomes are separated by the word or, then we're going to add. So we're looking for black or blue, so I'm going to add my 2 probabilities. If the outcomes are separated by the word and, like these, I'm wanting a black and a black, I'm going to multiply. So that's just a little hint. So if you're looking for an and, you multiply. And if you're looking for an or, we add. All right, so I did my multiplying when I found my black, and I multiplied when I did my blue and blue. Now I'm looking for a pair of black or blue. So I'm going to take my 2 numbers, I'm going to add them. So my probability, let's say that of black, I'm going to do my probability of black plus my probability of blue. That would be 3/8, which is the black, plus my probability of blue, which is 1/8. That would be 4/8, reduces down to 1/2. So I have a 50-50 chance of getting a pair of black or a pair of blue. Go ahead and click on the link and complete the homework, and we'll practice some more when you get to class. Have a good night.